See, some next topic is some important compounds of the transition element, that is oxides and oxoanions of metals. First, you must already know that oxides. Then oxoanions. What are oxoanions and oxocations? Oxocation, oxoanion. See, just this is the polyatomic ion. That is, the polyatomic ion combined with contains one or more oxygen. One or more oxygen is called oxoanion. That is, similarly, polyatomic ion that is contains one or more oxygen contains the cation means that is polyatomic oxocation. Example, V2O plus like this. So V2 VO plus like this. One or more oxygen contains there is cation and anion respectively. So that the oxocations and the oxoanion respectively. See, the highest oxidation number, the all metals that is except scandiums form that is metal oxide. Then the oxide which are ionic, that means which are ionic. So that the highest oxidation state, the coincide with the group numbers of attained, that is scandium oxide to form 2 manganese Mn2O7. So the beyond the group 7. So up to this group 7, up to manganese group is 7, group 7. Beyond that group 7, the higher oxides, iron above like this, Fe2O3 are known. That is, beside the oxide, the oxocation stabilize the V5 plus as vanadium. That is vanadium 5 plus and vanadium oxide 2 plus. So that similarly 6 as vanadium 2 plus and titanium like this, titanium 4 plus as titanium oxide 2 plus. So this is called oxocation. So oxocations and oxoanions like this. Then here the oxidation number of metal increase, the ionic character decreases. Usually the oxidation state of metal, that is that ionic character increases, the metal increases, the ionic character decreases. Ionic character decreases. In case of manganese, like in case of manganese and Mn2O7 is a covalent, that is a green oil, even the chromium trioxide CrO3 and vanadium pentoxide V2O5 have low melting point. So these higher oxide, that is acidic characters predominant. So that here that's the Mn2O7 gives HMnO4 and CrO3. This one CrO3. There is CrO3 gives HCrO4 and H2Cr2O7 like this. See, the amphoteric mainly the acidic, and it gives VO4 3 minus, that is vanadium tetroxide 3 minus, as well as that V2 plus VO2 plus, that is solved. The vanadiums are gradual change from the basic, that is V2O3 to less basic, that is V2O4 and V2O5 is amphoteric. Okay, this is basic, this is less basic, and this is amphoteric. This means both acid and base characters. That means react. Then there is the well characterized CRO, that is CRO is a basic, but in Cr2O3 is amphoteric. So this is the mains of the oxides and the oxoanions of metal. Now the next is the potassium dichromate. How will you prepare the potassium dichromate? Then the structures we will discuss now.
Okay.
Here the next is the potassium dichromate preparation. That is very important in the leather industries. There is an oxidant for a preparation of many azo compounds. So The dichromates are generally prepared from the chromate. That is, which terms are the obtained from fused chromate ore, that is Fe Cr2O4. This is fused chromite ore. Chromite ore. Fused chromite ore with the sodium carbonate. With the sodium carbonate Na2CO3 in presence of air, this or potassium carbonate. You can use for sodium carbonate or potassium carbonate in free access of air. That is 7 moles of oxygen to produce sodium chromate. This reaction is Na2CrO4, that is 8 moles of Na2CrO4 and 2 moles of 2Fe2O3 and 8 moles of carbon dioxide gas. So this is the yellow color. This is the yellow Na2 or sodium chromate. This yellow color, yellow in color solution. The sodium chromate filtered and acidified with sulfuric acid gives solutions of orange sodium dichromate. So react with this, the Na2CrO4, is 2 moles. React with the acidified, that is sulfuric acid, to form sodium dichromate, Na2Cr2O7. So this is orange sodium dichromate. This can be crystallized in the form of, that is Na2Cr2O7.2H2O. Okay, this is the sodium dichromate is more soluble than potassium dichromate. So later see the prepared, that is on heating Na2Cr2O7 and treatment with potassium chloride to form potassium chromate Cr2O7, K2Cr2O7 and NaCl. Okay, so that orange crystal is of potassium dichromate, that is crystal of the chromates, and chromates are interconvertible in aqueous solution, that is depending upon the pH value. That is reaction is for chromate converts to dichromate CrO4 minus react with the acid, it converts to Cr2O7 2 minus H2O. So this is chromate to dichromate. Similar way, dichromate react with the base to interconvertible. So here Cr2O7 2 minus react with base to produce 2Cr O4 2 minus H2O. So this is the interconvertible of, there is chromate to dichromate, dichromate to chromate, that using of acid and base. Okay.
Okay.
Structure of chromate ion and dichromate ion. Now first I will draw the chromate ion. Just the structure of chromate ion is CrO4 2 minus. So just put a Cr here. Just oxygen, 4 oxygens are present. So just put oxygen 4. Then 2 minus. So just the charge is 2 minus. So this is the structure of chromate ion. So the structure looks like a tetrahedral. The tetrahedral. Similar way, the dichromate ion, just flip this. The same thing, just write this. So just flip. Then the formula is what? Cr2O7, that is Cr2O7. Just put a oxygen here, right? Then again put a chromate ion, just connected with this. So here also the charge is what? 2 minus. The charge is very important. You have to draw the oxygen like this, chromium oxygen like this. Why? Because mean the bond angle is 126 degree. so that we are writing the bond angle is this. Here the bond length, chromium oxygen bond length is 179 picometer, and this chromium, all this chromium and oxygen bond length is 163 picometer. So this is the structure of chromate and dichromate ion. The first one is chromate ion and the second one is the dichromate ion. This is the tetrahedral sharing of one corner. This is the one corner sharing. So that this is also the tetrahedral nature. The bond angle of the dichromate ion is 126. So and sodium and potassium are very strong oxidizing agent. There is sodium and potassium dichromates, not sodium and potassium. Sodium and potassium dichromates are strong oxidizing agent. Like the sodium salts are greater solubility in water and extensively used as an oxidizing agent in organic chemistry. So the potassium dichromate used as a primary standard in that what is it called, redox reaction, volumetric analysis in acidic solution. That oxidizing oxidizing action can be prepared. That is the Cr2O72 minus react with H plus 6 electrons plus chromium 3 plus 2, so that is why 6 electron, so losses of 6 electron to oxidize Cr2Cr3 plus and 7 H2O. So here the standard electrode potential value is 1.33 volts. Then the acidified potassium dichromate will oxidize to iodine. Will oxidize, that is 6I minus gives 3I2, that is iodine 6 electron. Similarly, the sulfides to sulfur, tin to tin 4, that is tin to tin 4, and iron to iron 3. Like this. This is the half reaction I will write here. Hydrogen sulfide is gives acid and 3s 6 minus 6 electron. So similarly the tin 3SN2 plus gives 3SN4 plus and 6 electron. 6Fe2 plus gives 6Fe3 plus and 6 electron. So this is the half reaction of this. The full ionic equation may be obtained the adding of half reaction for the potassium dichromate to the half reaction for reducing agent. For example, I will write here the equation Cr2O7 2 minus plus 14H plus 6Fe 2 plus gives 2Cr3 plus and 6Fe 3 plus and 7 H2O. Okay, so here the electrons are cancelled and then the remaining net equation is this. Okay, then next is the potassium permanganate. How to prepare the potassium permanganate and the uses. So potassium permanganate, next is potassium permanganate preparation. It is prepared by fusing of manganese dioxide. The manganese dioxide Mn2MnO2 with alkali metal hydroxide, that is sodium hydroxide or potassium hydroxide. So here react with the alkali metal hydroxide on oxidizing agent, that is an oxidizing agent like KNO3, potassium nitrate. This produce the dark green color potassium manganate, that is K2MnO4. That is oxidizing, undergoes oxidizing agent using of potassium nitrate K2MnO4, that is potassium manganate, and water molecules are obtained. Then this manganate ion 3MnO4 2 minus, that is this undergo this is dark green. The color is dark green, which is disproportionate the neutral acidic, neutral or acidic solution to give permanganate ion. React with neutral or acidic, that is 4H plus to give 2MnO4 minus. So manganate to permanganate, then manganese dioxide MnO2 plus H2O. So this is the commercially it is prepared by the alkaline oxidative fusion of, that is manganese dioxide, that is followed by the electrolytic reaction oxidation of manganate 6, that is M1O2, the M1O2, this fused with KOH oxidized with or KNO3, that is air or KNO3. You can use air or KNO3 to form the manganate ion MnO4 2 minus. This is manganate ion. This further, the manganate ion MnO4 2 minus, it undergoes electrolytic oxidation, that is with alkaline solution, to form MnO4 minus, that is permanganate. Okay, this is first one is manganate, second one is the permanganate. Then this the laboratory, this is manganese 2 ion salt is oxidized by the peroxo disulfate to permanganate. For example, 2Mn2 plus peroxo disulfate, so that 5S2O8 24 react with water to form 2MnO4 minus, so permanganate, and 10SO4 2 minus and 16H plus. So this is the potassium dichromate forms a dark purple, almost it look like a black color, but when dissolved in water, the solutions and dark purple color, purple in color. So this is not very soluble in water, that is isostructural with the potassium chloride, but when heated with decomposes to give potassium manganate like this. See, the KMnO4 react with to give, that is decomposes and high temperature, that is 513 Kelvin, to gives K2MnO4 and MnO2 plus O2. So this is the intense color and its weak temperature, that is depends the paramagnetism. This is the physical properties of this compound. This can be explained with the help of molecular orbital theory, which is the beyond your study limit. Okay, I will draw the structure of the manganate ion and the permanganate ion. Structure of manganate and permanganate ion. So manganate ion is MnO4 minus, 2 minus, and another one is MnO4 minus. So one is green, another one is purple. So first I am going to draw the manganate ion. So manganate ion MnO4 2 minus. Just draw like this. This is a tetrahedral form of this. So just put oxygen in all the bond, connecting bond. The remaining 2 minus charges are the negative charge, so just put here. Then valence just 6, so put a bond like this. So this is the manganate ion structure. Then the permanganate ion structure, just like the same way. This is also tetrahedral in nature. Put a oxygen in all connecting bond into the manganese metal atom. Just put how many minus charges here? 1 minus charge. Just put here. Then remaining oxygen valence is to just put a oxygen bond like this. So this is tetrahedral manganate. This is the tetrahedral manganate ion, that is green in color, and this is tetrahedral. This is a tetrahedral permanganate ion, that is in purple in color. Okay, so the green manganate, that is the green manganate ion, is a permanganate with unpaired of electron. This is having unpaired electron, but permanganate is a diamagnetic. So this is a paramagnetic, this is a diamagnetic behavior. Okay, the magnetic behavior is paramagnetic and this is a diamagnetic. Okay, now this is the pi bonding takes place because of the pi bonding is here present here. The pi bonding takes place by overlapping of p orbitals of oxygen with the d orbital. So the orbitals of manganese. So that acidified permanganate solution oxidizes oxalate to carbon dioxide, iron to iron 3 plus. That is iron 2 plus to iron 3 plus, nitrites to nitrates, iodides to free iodine. That is this half reaction can be written here C2O4 2 minus. This is oxalate ion. On heating, what happened? It converts to carbon dioxide and 10 electrons. This is half reaction. 5 Fe2 plus to oxidize 5 Fe3 plus 5 electron. Similarly, nitrite to nitrate, 5 NO2 minus gives 5 H2O gives 5 NO3 minus plus 5 NO2 plus 5 H2O gives 5 NO3 minus. This is nitrite to nitrate and 10 H plus and 10 electrons. Similarly, iodide ion to iodine, that is free iodine, 5 I2 plus 10 electron. So this is the half reaction. The full reaction can be written the adding of half reaction, that is for potassium permanganate to half reaction to reducing agent, balancing whatever the necessary equation. So we can represent the reduction of permanganate to manganate, manganese dioxide to manganese to salt by the half reaction. MO4 minus plus 1 electron loss to gives MnO4 2 minus, manganate permanganate to manganate. So the electrode standard electrode potential value is plus 0.56 volt. Here the next is MnO4 minus, for react with acid, there is 4H plus 3 electrons losses, sorry, gains to MnO2 plus 2H2O. This electrode potential value is plus 1.69 volt. Then MnO4 minus 8H plus, increasing of acid, 5 electrons loss, sorry, gains, and Mn2 plus 4H2O. The electrode potential value of this is plus 1.52 volt. This is having the electrode E0 value is plus 1.69 volt and this 0.56 volt. So this is the electrode potential value of this. Okay. So this increase the hydrogen ion concentration of the solution plays an important role. So increasing the H plus ion, so the values are changes and this also changes. Okay. So all the many reaction can be understood by the considering of the redox potential, like kinetics, reactions also importance factor. Okay. The permanganate ion, that is H plus, concentration of H plus is equal to 1, should oxidize water, but it practice in the reaction extremely salt. That means that is extremely slow. So that unless either manganese 2 ions are present, the temperature is raised. Some more examples are given here. That is in acid solution. In acid solution, iodine liberated to form potassium iodide. See, iodine 2 MnO4 minus 16H plus gives 2 Mn2 plus and 8 H2O plus I2. So iodine, iodide to iodine, 5I2. Then Fe2 plus ion, that is green, converts to Fe3 plus, that is yellow, green to yellow. 5 Fe2 plus react with permanganate ion 8H plus to gives Mn2 plus 4H2O 5 Fe3 plus. So here there is green, Fe2 plus is green, this yellow, Fe2 3 plus is yellow in color. Then oxalate ion to or oxalic acid, and that is oxidized at 333 Kelvin temperature. You will be getting that is in your practical. We are using this reaction C2O4 oxalic acid versus potassium permanganate reaction in volumetric analysis. So 2MnO4 minus 16H plus 2 gives 2Mn2 plus and 8H2O plus 10CO2. So when the temperature is the range is 60 to 70 degree Celsius, 60 to 70 degree Celsius. So the carbon dioxide gases are liberated. Then the reactive with the potassium permanganate, the reaction will proceed faster. Otherwise, very slow in the reaction. Okay, that is the end point appearance in that nearly around 17, 16. That depends that concentration of that potassium permanganate. That is unknown concentration. Okay. Hydrogen sulfide. Here the hydrogen sulfide is oxidized to sulfur. This that is being a precipitate, H plus and S2 minus. So hydrogen sulfide oxidized to sulfate. That is then sulfurous acid or sulfide is oxidized to sulfate or sulfuric acid. So 5 moles of SO32 minus, that is sulfide, react with the potassium permanganate, and 16 H plus, that is acid, presence of acid. You will be getting that Mn2 plus and 8 H2O plus 5 sulfur, 5 moles of sulfur. Then that's sulfurous acid, like sorry, just I made a mistake. See here that 5S2 minus, that is sulfide, react with the 2MnO4 minus and 16H plus. This is the correct one. It gives Mn2 plus and 8H2O, 5 sulfur. Then sulfurous acid or sulfide is oxidized to sulfate or sulfuric acid. This is the 5SO3 2 minus plus 2MnO4 minus 6H plus, not 16H plus. This is 6H plus gives 2Mn2 plus and 3H2O plus 5SO4 2 minus. Then nitrate to nitrate, that is oxidation of nitrite to nitrate, 5NO2 minus, this is nitrite, react with permanganate, 6H plus in the presence of acid, we will be getting 2Mn2 plus and 5NO3 minus. So that this is nitrate, this is nitrite. In neutral or faintly alkaline solution, there is a notable reaction of iodide to iodate. For example, that is 2MnO4 minus react with iodine to form MnO2 and 2OH minus plus iodide, IO3 minus. This is iodate. Iodine to iodate. Then thiosulfate is oxidized, that is to sulfate, 8MnO4 minus 3S2O3 2 minus plus H2O gives 8MnO2 plus 2OH minus and 6SO4 2 minus. Then the manganese salt is oxidized to MnO2, that is manganese dioxide, presence of zinc sulfate or zinc oxide, that is catalytic oxidation. The reaction is 2MnO4 minus 3Mn2 plus 2H2O gives 5MnO2 and 4H plus. So this usually the permanganate titration is the presence of hydrochloric acid. Suppose using of hydrochloric acid, this is unsatisfactory. Then the hydrochloric acid is oxidized to chlorine. That is why we are using sulfuric acid, dilute sulfuric acid. Okay. Then uses the uses of potassium permanganate is there is a oxidizing agent in laboratory analytical chemistry, that is in bleaching of wools, cotton, silk, like this, textile industries. Then decolorations of oils, that is and also the strong oxidizing agent. This is the uses of the potassium permanganate. The next is we will discuss the inner transition element, that is called F block elements. Okay student, thank you.